Welcome to Making Waves, the podcast where we spotlight real projects at Kleinschmidt and the people who bring them to life. I'm Ben Carey, and in each episode, we go behind the scenes of a project, the challenges, the innovations, and the human stories that bring them to life. Today's guest is Steve Parker, a senior engineer and systems section manager here at Kleinschmidt. We'll be talking about a turbine inspection project, which is very fun, very different from what we talked about in the past. And I'm really excited to get into this with Steve today. So let's dive in and make some waves. Welcome to the podcast, Steve.
Hey,
Appreciate you
thanks
being
for having
willing
me
to,
on. I appreciate it.
yeah, appreciate you being willing to hop on today. Excited to have you. Let's start off with just a little bit about what your role is at Kleinschmidt and how you ended up working in the hydropower industry.
I'm a second generation hydro engineer. My dad was also in hydro. So
Very cool.
yeah, he was a chairman on the board for IEEE, was an electrical engineer, and he worked as a generator engineering manager for some of the larger OEMs for GE and Siemens back in the day. And
Okay.
he started his like a consulting firm in Sarasota, Florida. And that was like back in the 80s. It was called GPEA. And when I was a kid, I worked in his shop. He had like a manufacturing company. It was kind of a manufacturing and consulting firm. Anyway, so I would work in the shop when I was a kid, and when I after I got my degree, I joined him in the office. So
Okay. So started working for your dad. How did that transition? I guess was he consulting for hydro clients at the time?
yeah, so
Okay.
he on the engineering side, he would do component design, but he was also doing uprate studies, which is figuring out, if you were to change out your turbine, what sort of changes could you do on the generator side, and kind of stair step the here's the least expensive and go on from there and see how much power you could get out of that unit. So yeah, it was a lot of fun. Got to crawl a bunch of units when I got my mechanical engineering degree, and his electrical degree and my mechanical degree, that we worked well together. So yeah, we were also manufacturing subcomponents for generator units. So we would make air coolers. That was my claim to fame. We've got quite a few of those, and we would do other various things, whatever folks needed. So
And
yeah,
and then how did that transition from that to coming on at Kleinschmidt?
yeah. I was there for like 9 years, and then I started working with Andritz. I worked there for about 13 years.
Okay.
And that was like project engineer to working at site to I started managing quality and I ended up doing project management and ended up managing project managers. And uh, that was before I came on with you guys. So really happy to be working with Kleinschmidt now. It's the best. Uh, And my role now, I'm an engineering manager, just like my dear old dad. And I manage electrical and mechanical engineers here at Kleinschmidt. We've got about 14 folks, give or take. Some folks are part-time. But
Gotcha. And what does a day-to-day schedule look like for Steve Parker?
does a day-to-day schedule look like? Well, I help out our folks. That's the best part about the job, is that the role is really focused on helping the engineers to develop from where they are to where they can be, or would like to get to. And
Mm,
that's the most exciting part about my job. I get to help people focus on things that can increase or remove obstacles of what's preventing them to succeed in their roles. And so yeah, and I'm also kind of act as an advocate for the people on my team, and that's also exciting to do. um, but yeah, just sort of, and also working as a mentor after I have over 22 years of experience in hydro, and so there's often things that I can add to the equation Um, sometimes make it more complicated, and sometimes I can simplify things. But yeah.
Very, very cool. So besides the obviously the family draw of getting into this industry, I'm assuming there was something else about hydro that, either sparked your interest now or sparked your interest back when you were deciding what you wanted to get into.
Oh yeah. So when I was a kid, my dad was getting an award uh, from Duke Energy, and he drove us all the way up into North Carolina to receive this award. And we actually got to go to um, the a plant called Bad Creek, which if you've not, I don't know if you're familiar with Bad Creek. Okay,
No.
no, it's great. It's a pump storage plant, but it's like the Bat Cave. You have to go down this
Oh,
really, yeah, it's like drilled down into the mountain at this inclined. And so you're just, driving into the mountain. And then you finally get to this place that's all lit up, but it's got the units in there, but it's also, got like wire cages along the walls to keep the rock from falling, I guess. I don't know. When I was a little kid, I was really into Batman. And here's this like I got to visit the Batcave. So anyway, it was that was one moment. We often have I don't often talk about this, but we'll encounter a bunch of things that are just meant to be thrown out. A lot of our lives are spent. We've got trash from McDonald's or whatever. That's something that was made by a person and it's not meant to hang out. And here in hydro, you get to see things that were meant to last literally forever, and they
mm,
are these incredible, human endeavors that will, long outlive us, and it's just so cool to be a part of that. I was I was watching a series with my wife, and it was like a historical series, and they were like English historians who were doing some reenactment, and they were doing it in this village, and they took the wool off of the lamb, and then they made it into some sort of cloth, and then they brought it to some sort of water mill, and the water mill just beat the snot out of this textile to make the fabric come together. And I was like, oh wow, that's great. This guy made his whole life off of the power of water, and then and it struck me like, okay, we well, I actually like off of the power of water. Wait a minute. My whole livelihood, I've been able to raise my kids and stuff just off of the power. It was just like, oh, and my dad too. Like, so my whole life. Anyway,
yeah,
pretty
that's a
cool.
great story. So it sounds like in lieu of being able to become a superhero, you settled for becoming a mechanical engineer. It sounds like.
Yeah, yeah, okay.
Cool. Well, that was a great introduction, Steve. Appreciate the background on yourself and how you got into hydro. I'm going to transition here to just some rapid fire questions, some get to know yous, and then we'll start talking about this turbine inspection project.
Sure.
So first and foremost, have you ever been on a podcast before?
No.
Oh, come on. You'd actually be surprised. There's actually been a few people that I've interviewed that have been on podcasts in the past, which is
Oh,
kind of
wow.
funny. Yeah, yeah. Well, welcome to your first podcast.
Thank you. Thank you.
If you had to choose between being in a really comfortable office chair during the workday or being out in the field in boots, which would you choose?
Oh, yeah. Get me the boots for sure.
Okay.
Yeah. Yeah. Working at site was a lot of fun, and I kind of miss it. Every day was another challenge, and you're able to put your hands directly on the problem.
Yeah, on the being around those things, those projects and that infrastructure that's going to outlive us, like you just said, right?
Right.
Super,
Yeah.
super cool. What about if you had to choose and you can't say both? People try to say both on this question. You got to pick one.
Oh man.
Coffee before work or a cold beverage after work?
Oh my goodness. Oh man. I didn't know I was going to be put on the spot. All right. So meaning I get one or the other
One or
tomorrow.
the other. Yeah, yeah, yeah.
Oh man. Yeah. Okay. So I'll probably just struggle through and get the cold beverage afterwards.
Okay, okay, yeah. I respect it. Yeah, keep
just
the
just
eyes on
give
the
you,
prize.
you gotta slap your face, you keep it moving.
Yeah, you can have some tea or something, right? There's some other things you could have in the morning. So
Yeah,
yeah,
yeah, yeah,
yeah.
yeah.
What about would you rather live without electricity or live without shoes?
Oh man. Yeah, I'd live without shoes. Let's do that.
Okay, yeah. You're
I
comfortable
grew up in
inside.
Florida, so I'm okay with that.
Fair enough, fair enough. Yeah, I just interviewed one of our Canadian staff, and Northern Canada was not a place that you can go without shoes. So he had
No, not really.
and then last one, cats or dogs?
I have recently brought a mutt from the pound into my home, and I I still don't know the answer to that question.
Okay, okay, that's okay.
He's
Yeah.
so much trouble. It's just oh boy. And I'm coming on the 4th of July here, so no, we love that dog, and so I've got to say I'm a dog person now.
Okay, fair enough. Well, that you're one of many here at Kleinschmidt. That's
Yeah,
definitely for sure. No. All right, let's talk about this project. So, give us the big picture. What was this turbine inspection all about? For those maybe that aren't familiar with what turbine inspections is all about, and if maybe there was a particular aspect of this inspection that was different from other inspections that you worked on in the past.
sure. So yeah, it's a great question. So this is a turbine inspection that was occurring during a kind of a unique um, dewatered condition. So I was able to look at multiple units all within the span of a few days
Okay.
and really go through them, do some operational testing as well as get a good sense of what's going on with the turbines themselves. Now you're going to hear me say turbine, okay? It's going to happen a lot. All right, I know that most people say turbine, but it is a thing in hydro, and I don't know why. We just say turbine, and I can tell you because I'm the second generation that has been going on like this forever. Okay, I'm not about to change for this this podcast. Anyway, so yeah, it was a unique opportunity to get down there in a dewatered condition and have a look at these things. Now, you had a second part to this question.
I guess if there was anything unique about this turbine inspection, different from other ones that you've done in the past.
Yeah, other turbine inspections. I've been to uh, a lot of turbine inspections overseas in China, through Europe too, where you're able to see it on a shop floor. You're able to, you have access to a crane, and you're able to, look at every portion of it as well as see how it fits together and get some, taking measurements while something is in on a shop floor. It's a much easier condition, or on a machine. So yeah, this is installed, and so I got to see it where it was sitting, which is I guess the condition that you're going to be doing this for the most part. You're going to be having a look at these in situ. So
Gotcha. And was this inspection just related to general maintenance? Was there like an event that occurred that had you guys go out there? Like, what was the reasoning for you to be out?
yeah, so they had the company had seen that there was some deterioration, and they wanted to over the years, and they wanted to do an update to their previous reports to see how things were, or if they needed to change the way that they were doing things.
Okay, got it. And were there other, besides the client, were there other key partners or stakeholders that were involved in the inspection, or was it just pretty much the client and you?
Nope, it was just the client and myself. Yeah.
Okay, okay. So let's then talk about some challenges and maybe some problem solving associated with this particular inspection. So obviously every project, including inspections, have their own challenges, whether it's safety related, site access, or maybe something else. Thinking back on this particular inspection, what was one of the or maybe some of the biggest challenges that you faced with doing this?
Um, not a lot of challenges. We typically when you go in for an inspection on a turbine, you think there's a couple of different routes that can go. You either have an issue with cavitation, or you have an issue with erosion. There is also the option of having your material starting to break down, which is possible. These are typically stainless um, components, and it could be that you've got something that in the water that's actually attacking that stainless. So um, that's in the South, we get kind of the other two. You get water that's attacking your turbine, and you get a an issue with erosion. We've got a lot of mud, a lot of silt and things moving through our water, so we're pushing through a lot of sand, and so these units in particular were um, highly affected by kind of sandblasted throughout their life. So
Gotcha. Okay. You mentioned a word there, cavitation. We talked a little bit about this before we started recording here. For those that maybe aren't familiar, at a high, 10,000 foot level, what is cavitation and how can that impact,
yeah.
turbine units
So
specifically?
cavitation is has to do with pressure drop. So it's where your the local pressure of a liquid drops below its vapor pressure, and you get these like tiny vapor bubbles to form. It's
Okay.
like little tiny explosions really close to wherever the material is. And
Okay.
yeah, so um, yeah, that's not good.
And is that a situation where some projects are designed to be able to absorb cavitation, or if that's going on, something didn't go right in the design or the operation of the project?
Right. Usually you try to cover this during the design, but you got to remember that a lot of these units were made long before CFD was a twinkle in anybody's eye. So you just so they're just kind of trying to patch over old areas where there's cavitation and just trying to readdress the same locations over and over again with building up weld.
Gotcha. Yeah, and CFD for those that maybe not familiar is computational fluid dynamics. It's basically, it can be, uh, I guess, described as 3D modeling, right? Which kind of is helpful in assessing where inside of a project there might be some cavitation concerns. Is that right, Steve?
That's right.
Okay, I know a little bit about CFD. Well, yeah, that was a great description there on kind of some of the challenges that can typically affect turbines and what you're looking for when you're inspecting those. So thanks for the summary there.
Sure.
Um, in terms of maybe some of the relationship or people aspect of this, I know you said it was obviously just yourself and the client, but in thinking back on the project, was there anything that you really enjoyed or appreciated about the project as it pertains to kind of the people that you were working with or the client or whatnot?
Well, I mean, the client was a delight. They were willing to put in, uh, and it's considered a confined space, and so in order to enter that, you've got to have the conditions right. You've got to have air monitoring in place. You've got to have folks that are going to be watching your exit, and making sure that you're going to stay communicating with you, and so they were willing to do that portion of the work with me. So and you know it's greatly appreciated when we can get that done and don't have to outsource all of the kind of the peripheral safety requirements that they're important, but at the same time, these are folks who have been doing it for a long time. They know their location better than anybody, and so um, I was, and they were really nice folks to work with in general.
Yeah, yeah. Speaking of, you brought up kind of the idea of safety and how obviously the client played a role in making sure that your inspection, was conducted safely and all that. One of the really interesting things about hydro, the hydro industry in general, is how a lot of these inspections obviously have sometimes pretty significant safety components to them, right? Just because
Hmm.
we're in areas that aren't the safest to be. There's a lot of
Yeah,
different things
yeah,
that can potentially go wrong. So I guess if you'd maybe just talk about for a minute for a mechanical or electrical engineer that's out there that is not in the hydro industry, just kind of what some of those potential, I guess, hazards are about working in hydro, and how that in some cases is actually pretty cool that we get to be exposed to some really cool environments that most engineers that are just working in an office every day don't get to experience. What is that like?
Sure. Well, let's talk about this inspection in particular. You're going down a ladder from a hole, and tools are lowered down to you, and then you're down in the scroll case, which is kind of, if you think of a snail shell. This is where the water is entering into the unit, and then the cross-sectional area of that tube is kind of going smaller and smaller until it surrounds the turbine.
Okay.
And so this particular unit was a Francis unit. And so you have nothing about that is flat, really. It's all of it's curved. Everything's changing. There's a change in elevation, and it's like I said, it's a muddy condition. So you're kind of climbing around on a slope, trying to get your measurements and a sense of what's going on. Sometimes you're working in dark conditions, or in some plants you'll have issues with you'll have like zebra mussels and things like that are kind of chittering and dying on the walls, and you and they could, the shells there could be sharp. So we gear up. We've got our gloves and hard hat, safety glasses, and Tyvek. You're going to want a suit on so you can go to lunch later and not have muddy clothes. But yeah, and typically confined spaces require you to wear like a oh fall protection harness so they can drag you out if something, the worst case condition happen. But thankfully nothing bad happened on this
Yeah.
trip.
And is that for you personally? Is that like does that make the site work a little bit more fun and exciting, or do you not like the risk aspect of that?
Oh, it's just part of the job.
Yeah. Okay, that's fair enough.
Yep.
All right. Lastly, just want to talk to you a little bit about kind of the results, or yeah, I guess results of the project. You mentioned the fact
Mhm.
that this particular turbine had seen some erosion from, it sounds like, sediment exposure.
Right.
Was there any other, I guess, conclusions that came out of your inspection that maybe led to actions that the client either had to take or chose to take?
Yeah. So they right now they're looking at their budget, but the main thing is that they had some severe scoring, not only on the rotating components, but on the stationary components. So with a Francis unit, you've got an upper rotating wear ring and a stationary wear ring, and a lower wear ring and stationary, rotating and stationary ring. And so these were the bottom one especially was really getting worn out. I can put my hand in there, and it's only meant to be a few thousandths.
Mm,
So it's just so much sand moving through there that it's opening up the gaps and reducing the efficiency for the unit. So um, this particular unit, of course, we were suggesting that they made repairs to the inside corners of the buckets, the blades, um, that were worn out, as well as the wear, the stationary wear ring. So it would mean a complete disassembly and replacement of those wear components. I also suggested that they replace their wicket gates. This is something that we typically suggest. It's not a heavy expense, and if you've got something that's you know going on 70 years old, maybe it's time, time to just lay those out in the yard and bring in some new ones. As far as expenses go, this is not a big one. So
gotcha. Okay, no, that's a great perspective there. I guess if the client were to choose to not make some of these changes, what would be the potential outcomes of doing so? Is it just loss of efficiencies, or actually, like, a risk of compromise within the unit itself? Like, what are the potential negative outcomes?
these particular units, they didn't have any cracks and I could find there was nothing along those lines, it's going to continue to deteriorate and reduce your efficiency to, I mean, yeah, at some point, yes, you'll have something catastrophic happen where you've completely, wore through a blade and then it falls off or gets stuck. And yeah, that's a lot of destruction. So, but they were, and then again, it's what are you doing to your bearings if you've got so much gap at your thrust? So.
Gotcha. I'm sure there's a lot of folks that are listening to this story and are like, man, it'd be really cool if I had the chance to be able to go out on an inspection like this with and actually see something real, right? That is functioning and that maybe even you had a part in designing. Are there multiple people within your group that get to do these inspections? Is there a certain level of experience that you typically need to get before somebody's able to go out and add value to an inspection like this?
So I'll bring whoever wants to go. I actually got to John was on a separate job and Jonathan and so I pulled him in for the last day and he did some TD with me. Got to use the feeler gauges to find out what the gap was and take pictures and we were also doing some operational testing with the wicket gates and opening and closing closure times and gaps there. And so he helped me with that. But yeah, Ben, you want to go? I'll bring you too.
No, I think it's cool that at Kleinschmidt, obviously we have very skilled, experienced people that are sought to come do these types of inspections, but it seems like um, it's common that those people are willing to bring along more junior staff
Right.
to help learn and ultimately be able to do those inspections one day themselves. So I just
Yeah.
appreciate that about you and about the other people at Kleinschmidt that kind of
No,
lead
I,
these inspection
I
efforts.
I enjoy that as well. And I talked to my younger engineers about, okay, let's go through it. Let's, explain why all these things work the way they do. And they're, really happy to know that Kleinschmidt works this way. It's such an open environment and people are really wanting to teach and mentor the junior engineers. It's not something that I necessarily, outside of working for my dad, it was, if you want some information, you got to do it the hard way, or you're going to be, people. It's a completely different planet, and I really enjoy it.
Yeah,
Um,
super cool. When do you get to go back out? Do you have any plans to do another inspection in the near future?
so I was out this week, and I expect I'm going to take some vacation Monday and Tuesday. I'll be on another inspection next week. So,
Awesome. So
yeah.
cool. And then I guess just last topic here before we sign off for today. Just thinking about a message to folks that might be tuning in that are interested in getting into hydro, they have a mechanical or electrical background. What sort of, I guess, advice would you give to those individuals about whether hydro is kind of the right place for them?
Oh, wow. Um, that's a really great question. So what makes it right for somebody? I think that it's if you're a mechanical or an electrical engineer, and you're interested in large parts and solving problems that are unique, this is combine that with some sense of I'd like sustainability in my, in the world's energy makeup. I think that it's a great fit for you. If you're really only interested in making parts or making, you know, small, some kind of widget better over the course of several decades, then this may not be the choice for you. But on the electrical side, we're mainly looking for folks that are um, interested in like facility design, people who are interested in controls and not so much the RF or like circuit board design. This is more, choosing major components and then trying to figure out how they interconnect and yeah, and make sure that everything is safe and protected. Um, as well as we do a good bit on the control side. On the mechanical side, we're doing design. We do quite a bit of fish movement, fish passage design. And so these are all Rube Goldberg machines that are lots of fun to try to figure out and try to get them all working together simultaneously. Constant water moving through them. It's a lot of fun. And then we also have a client has a problem and they need somebody to come and place a design a new bearing someplace else, or or this is cracking out. What do you suggest? How do we move forward? There's a generator where the rim is shrunk on. We need to figure out how we can remove this rim and replace this spider, or make repairs. And so that's things. These are the kind of things that we help folks with. Yeah, I think that most everybody would do well to go into hydro that's got a mechanical or an electrical degree. I think you'd be well suited to join us.
And then one of the themes that has come up on the last couple episodes of this podcast has been just around kind of the collaboration between different disciplines. And that's something that I really appreciate about working here, is just being able to work with folks that aren't H&H engineers in my case, that aren't mechanical engineers in your case.
Sure.
What are the typical groups that you and your team are interacting with inside of Kleinschmidt? Because one of our goals is that we obviously don't work in silos, but how does that look in practice?
I mean, we're working with everybody. I think that the folks we work with the least is probably the scientists. But we'll work on the regulatory side, the dam safety folks. We're working with civils, structurals, geotechs. We do work with, yeah, just about everybody. Yep.
Cool. That's awesome. And then last one here, what excites you? This is a very reflective, big picture question, but what excites you about the future of hydropower, just in general? There's obviously a lot of energy and momentum within the industry right now, a ton of work that's coming out, which is a great place to be if you obviously work for a hydro consulting firm. But from your perspective, what's the most exciting thing about where hydro is going?
Yeah, I mean, right now, in my career in the United States, almost everything that I've been associated with has been rehabilitation of existing units, facilities that have been around forever. And now with the call for all of this energy, you've got whether you like it or not, there's a large ask for energy in the States. And people are trying to figure out how this, we've Kleinschmidt in particular, we've done study after study of things that didn't pencil out over the years, and now folks are picking those back up again, and they're saying, well, now maybe it makes a little bit more sense. Maybe this is the direction we go. And so for hydros, I mean, getting into new facility design is super exciting. Or uh, and it's also moving into this whole let's take care of the fish. We've blocked off these rivers for so long. Let's get them moving. Beyond it, it's completely feasible. To give these folks their ancient habitats back. Let's do it. And so I don't know. We hydro in general is extremely fun because every plant you walk into it's completely different. There's no, even if it's made by the same manufacturer, they've got to deal with a different head. They've got to deal with a different flow rate, and everything on the arrangement of these units is completely different. And so they've approached the design completely differently. So the engineers back in the day, they had a lot of fun. And so the idea that we're getting back into times where we might have these same kind of fun decisions is exciting. I'm telling you.
No, that's a great summary. Steve, thanks so much for sharing the story behind this turbine inspection and just your perspective on mechanical and electrical engineering at Kleinschmidt. It's been great having you on. Any closing words for the folks tuning in?
No, thanks for listening.
Awesome. Thanks to our listeners for tuning in to Making Waves. If you enjoyed this episode, be sure to subscribe and share it with a colleague or a friend. And yeah, it's been great having Steve on. We look forward to our next conversation. Appreciate everybody's time. And until next time.